All right, so let's say that you got a question that asks you to find the distance between these two red points on a coordinate plane. It might be tempting to think about this as counting bunny hops diagonally, like 1, 2, 3, but actually you can't do that. And the reason that you can't do that is because the distance across diagonally across a square is not the same as the distance horizontally or vertically across a square. So if we're to zoom in on one of these coordinate grids, like this, and we were to take a square like this uh, this arrow measures the height, the base and height of the triangle. So the arrow is the same length as the height, and it's the same length as the base of our triangle, right? But if I were to tilt this triangle diagonally, it would not reach, it is not this, the length of this arrow is not equal to the distance diagonally across this triangle. It doesn't reach. And the reason for that is that this distance is longer. So if you're given a problem like the ones we're going to have on Delta Math, we cannot measure diagonally. We can only measure on the coordinate plane horizontally and vertically. Luckily, we have our Pythagorean theorem, which helps us find diagonal distances on the coordinate plane. So in order to use the Pythagorean theorem, of course, you have to have a right triangle. So you want to create a right triangle using the horizontal and vertical distances of the point to create a right triangle like I did here. And then you can use whatever method you want to count the length of your legs. So your horizontal and vertical distance. So in this case, our horizontal distance is 1, 2, 3, 4, 5, 6 bunny hops here, right? And then vertically, we're going from -7 to 1. So I know that my vertical distance here is 8. So one of my legs is 6 and the other leg is 8. It doesn't matter. You could also do 8 and 6. It really doesn't matter what the legs are, but we know that the C always has to be our hypotenuse. So if we recall our Pythagorean theorem, right? We said that our legs, A and B, right? This was our A is equal to 6 and B is equal to 8. So this would be 6 squared plus 8 squared is equal to C squared. That's 36 plus 64 is equal to C squared. And 36 plus 64 is 100 is equal to C squared. So what squared is equal to 100? Well, C has to be equal to 10 because 10 squared is equal to 100. I'm trying to find one that doesn't give us a nice problem like this. So let me clear this off. Clear it all. Actually, let me go all the way back out. Let me go to this problem on Delta Math. So that way we know coordinate distance rounding. So hopefully we don't get one that gives us a round numbers and we have to actually round to the nearest tenth, right? So again, we're going to create our right triangle using the horizontal and vertical distance. And in this case, we are going from -1 to 5. So this has a distance of 6, horizontal distance of 6, and a vertical distance from -1 to 7. This is the same one. So I'm going to go ahead and skip this one because we got the same leg lengths. Let's try this one. So from -4 to -7 is 3. I know that this one is going to give us a nice one again also because it's a 3, 4, 5 triangle. Let's try this one. This one is 2 and 9. I don't think that one will give us nice. All right. So this has a horizontal distance of 2 and a vertical distance from -1 to 8, which is 9. So let's go ahead and try this. So we have a leg length of 2 and 9. So that means using our Pythagorean theorem, we'll have 2 squared plus 9 squared will equal our hypotenuse squared. And our hypotenuse is going to give us this distance C. That's the distance that we want between the 2 points. So 4 plus 81, which is 85, will give us C squared. So that means that C has to be equal to the square root of 85. So C is equal to the square root of 85. So if I put that in my calculator, see what we get. The square root of 85 is not a nice number. So it looks like the square root of 85 is 9.2 rounded to the nearest tenth. So I'm going to put that in, 9.2 rounded to the nearest tenth. And that is how you would approach a problem like this, where you are measuring the distance between 2 points on the coordinate plane that are diagonal from each other. They're not perfectly horizontal or vertical from one another.